In this sublesson, we are going to see how to validate the information in the multicast topology. We'll be verifying multicast across the path, the PIM states, on the FHR, the LHR, and the rendezvous points, including the intermediate routers or switches. So looking at this topology, at this point, we do not have any multicast stream running. So we'll first initiate an IGMP join request from the receiver. If you are interested in configuring a static join on the Nexus switch, we can do that by getting into the configuration mode and interface Ethernet 1/1 and say IP IGMP join group and specify the specific group that you want to join from this interface. But since we are not doing that, we don't need to configure anything here. We should be receiving a multicast join from the receiver. So we have the multicast receiver already configured. So if you look at the receiver configuration, we have Ethernet 0/0, in which we are saying IP IGMP join group 239.1.1.1. So we are trying to join this particular multicast group. So go to the last hop router or the last hop switch, and we say show IP IGMP groups. If you're interested in configuring static joins, we can do that by getting into the interface and configuring IP IGMP join group and specify the group address. But since we already have a receiver attached and it has that configuration already done, we can look at the show IP IGMP join group, show IP IGMP groups to see which receiver is requesting for multicast stream. So in this case, we can see we have a receiver with asking for the group membership of 239.1.1.1. And if you look at the receiver configuration, we have IP IGMP join group 239.1.1.1. The same configuration applies for a Nexus switch as well if you want to statically configure a multicast or IGMP join. Since we now have an IGMP join from the receiver, the next thing we are going to look at is the *G entry. So the verification for a multicast always begins from the receiver and goes towards the source. It's the opposite direction of how we look at things in a unicast forwarding. Show IP mroute 239.1.1.1. And if you look at this, we can see that we have a *G entry. That means we are not looking for any specific source. And we have an uptime of 2 minutes. We have IGMP, IP, and PIM enabled. And the incoming interface is Ethernet 1/1, and the outgoing interface is Ethernet 1/2. 1/2 is where the receiver is connected, and Ethernet 1/1 is where the RPF neighbor is towards the rendezvous point. So let's go to this device, which is 10.3.4.3. It is on NX3. So we go to NX3, and we look at show IP mroute 239.1.1.1. And we can see we have the information. The incoming interface is Ethernet 1/2, and the outgoing interface is Ethernet 1/1. The Ethernet 1/1 is connecting to NX4, and the Ethernet 1/2 is connecting to the upstream rendezvous point. So we go to the rendezvous point next and validate this information. So we do show IP mroute 239.1.1.1. And we can see we have the *G here as well. And we only have PIM and IP. Notice that on NX4, when we were looking at this information, we had IGMP flag along with the IP and PIM flag. We don't see that on NX3, and we don't see that on the rendezvous point. Why? Because we are not sending the IGMP join up towards the RP. The IGMP join is just sent by the receiver to the last hop router. So now we have the *G built from the last hop router to the rendezvous point. Remember, the *G is only built based on the RP tree. This is from LHR or receiver to the RP. It does not go beyond that. So if you look at the same information on NX2, show IP mroute, we do not see that same group. And we won't see the same information on NX1 as well. Show IP mroute 239.1 106.1.1. We do not find that information. So the information is only present from the last hop router to the rendezvous point. Now let's start sending the multicast stream. On the multicast stream device, the device doesn't really need to know PIM protocol or IGMP. All we need to do is send the multicast stream by the source. If there's an application which deals with multicast, you just need to start the stream from that application or from that server. In this case, we have a device from which we are simulating a ping for the multicast stream. So we say 239.1.1.1, and we can have a repeat of, say, 100 packets, and the multicast stream is flowing. The reply is a confirmation that the multicast stream is successfully flowing from the source to the receiver. But let's validate the information across the path. So now, since we are dealing with the source, we first go to NX1. And let's look at the information for the same multicast group. At this point, we find an S(G) entry. The S(G) entry is the source from where we are receiving the stream and the group to which we are sending the stream. And the incoming interface is VLAN 100. VLAN 100 is the interface where the source is connected. So it's sending over the VLAN, and we have flags of IP and PIM. The outgoing interface is towards the upstream device, which is NX2. So Ethernet 1/1 is connected to NX2. So we go to NX2 and run the same command, show IPMRoute 239.1.1.1. And we can now see the information is 172.16.111.11, which is the source and our group, and PIM and IP flag set. The incoming interface is 1/1, outgoing interface is 1/3. Now, if I run the command show IP interface brief, what do I see? The Ethernet 1/3 is connecting NX2 to NX3, whereas the RP is connected to Ethernet 1/2. And you must be wondering why we are not seeing the information in the outgoing list towards the rendezvous point. The reason is because we have already performed an SPT switchover. The SPT switchover triggers a calculation for shortest path from the receiver to the source. And the shortest path, if we go back to the topology, we can see that from receiver, the shortest path is from receiver, NX4, NX3, NX2, NX1, and the source. The shortest path is not from the RP. If in case the link fails, in only and only in that case, the traffic will be forwarded in this topology via the rendezvous point. Otherwise, it will always take the shortest path tree. So NX2 has this information. But remember, our RP is also going to have this information about the S(G). Show IPMRoute 239.1.1.1. And we also have the S(G) entry. But the difference is the incoming interface is Ethernet 1.1. There's no outgoing interface. Why? Because we are not forwarding the multicast stream outside any interface from the rendezvous point. We have a PIM register. We received a PIM register from the source. And because we had the *G entry from the receiver, we sent a PIM register stop message back towards the source. Thus, we do not have any OIL forwarding the traffic down towards the LHR. So moving back to NX2, we have our S(G) entry built. The incoming interface is Ethernet 1.1, and outgoing interface is Ethernet 1/3. Let's now look at the device connecting Ethernet 1/3, which is NX3. So on NX3, we have show IPMRoute 239.1.1.1, and we can now see both *G and S(G) entry. The S(G) entry is what the source is taking the path to send or forward the multicast stream. The incoming interface is Ethernet 1/3, which is the interface connecting NX2. And the outgoing interface is NX1, which is towards NX4. So we go to the next device, which is the last hop device, the last hop router. And we run the same command, and we can now see Ethernet 1/2, which is the interface connecting the receiver as the outgoing list. This information is an end-to-end verification for the multicast stream from source to receiver and back.